All right, hi guys. So what we're going to be doing right now is going to be the hemostasis. All right, you are just going to need to realize that you're going to sit down with your book, read the chapters, and try to understand. Hemostasis and coagulation is very, very intricate and kind of complicated. It's not really complicated, it's just intricate with lots of different things coming in and out of the coagulation system, and I'm clotting and not clotting. I'm doing everything at the same time. So you go like, oh my god, I'm scared. Okay, what is going to save you? Let's see if we put this right. Hopefully you can see that. Your tables and boxes. Your tables and boxes in your chapter 35 and 41, I think that's what we're doing now, but all of the chapters, please look at those tables and boxes because they're going to give you so much information that you need. The other thing I need to say is that I'm going to be explaining the process and may or may not go exactly with, first we're going to do this and then we're going to do this. It's not going to be a specific sequence because everything works together. So it's going to be really, really fun. I really like hemostasis. It's awesome. And it is going to take a little bit of time. So please do not wait until 1 or 2 days before the exam to start studying this. It is going to take you some time to read it and know what's going on. Alrighty, so what I want to start off is that when we make a clot, you need to remember that it's very, very important for our system in our body to keep the clot in one specific area. Because if we don't, then I'm making clots everywhere and my body's freaking out, and then it thinks I'm bleeding and I'm not bleeding, and we go into a DIC and it's just horrible. So one of the main goals of hemostasis and what we're doing is to make sure that we keep the clot confined to where the injury is. Okay, the second thing you need to know is that the minute that I'm making the clot, I'm putting in a system to dissolve the clot. So isn't that weird? The minute I'm making the clot, I've got a system in there to dissolve the clot at the same time. All right, so what I have up here is a balance. So what you need to know is that hemostasis is a balance. And what's it a balance of? Procoagulants and anticoagulants. All right. Your again, what you're going to find in your book is the table that are going to list all the procoagulants, and they're going to label the anticoagulants. Now, what you need to remember, when we're talking about anticoagulants, it is not the EDTA and sodium citrate and all of those anticoagulants that you're used to finding in your Vacutainer tubes. So that's not what we're talking about. In our system, we have proteins and zymogens and all kinds of things that when they work together, they either are going to help a clot, a procoagulant, or they're going to take the clot off, anticoagulant. So remember, I said the minute we start making a clot, we have a system in there to dissolve the clot, okay? Or even stop the clot from happening. If I'm stopping the clot, it's an anticoagulant. Yes, I do have, heparin and some other stuff naturally in my body, but again, anticoagulants does not mean sodium citrate, EDTA, all of that. Okay, the other thing that's really, really important for you to remember is that all of the processes that we're going to be talking about, one of the most important things is going to be our endothelium. The endothelium, the exposure of the collagen and all like that. So the cells in our blood vessels are going to play a major role in our hemostasis. All right, so procoagulants over here, they're listed in table 35.3. In the notes that I actually gave you, it has the other chapters in there, but just look at that, anticoagulants. Okay, so when we're looking at hemostasis, procoagulants, anticoagulants, it's the balance. And what you need to know is that we have a primary, I think you can see that right? Yeah, primary hemostasis. And we have a secondary hemostasis. And yes, you have to know the components of primary hemostasis and secondary hemostasis. So we're going to talk a little bit about what's happening there. All right, so when we have our procoagulants and our anticoagulants, it is a balance. Now, what you need to know is that our platelets are going to play a huge role in this. So you know that, platelets. Okay, so our platelets, our platelets are going to provide the phospholipid surface area for the clot to be made. So platelets provide the phospholipid area. Phospholipid surface. All right, so what's happening? I'm cutting my skin. My endothelium and my blood cells are being exposed. Platelets are swooshing by. Remember, blood is swoosh, swoosh. It's going through my blood vessels. And then they see, oh, there's a hole in my blood vessel. So then the platelets stop and they provide a surface area for my anticoagulants to start working. All right, so this over here is going to be also very, very important for platelet aggregation. Platelet aggregation. Okay, so we're going to have another arrow here. Oh, I hope I have enough room. All right, platelet aggregation. So we have platelets over here, and over here we have our blood vessels. All right, so when we cut ourselves, or we get damaged, or I hit myself with a nail, or whatever, the endothelium, it gets cut, right? Cells are exposed, collagen is exposed. But at the same time, my body is going to recognize, oh my gosh, there's a hole. Whoosh, and the blood is going through. Whoosh, whoosh, whoosh. So what it's going to want to do is constrict. When the vessels constrict, it slows the blood down. All right, so what we're going to have, two things happening. And again, even though we talk about these like separate things that are happening, it happens all at the same time. It's crazy. All right, so we're going to have the vessels, and we're going to have vasoconstriction. And we're going to have platelet function, and vasoconstriction happening at the same time. Okay. All right, so I've got a cut, I've got platelets being involved here, providing a surface area. I have my blood vessels, which are giving me some of this endothelium stuff, and I have vasoconstriction happening all at the same time too. Now, I'm going to get a different color. So when we're talking about this type of system, about this, this is your primary hemostasis, okay? Your primary hemostasis. So we've got primary hemostasis is vasoconstriction, platelet aggregation, and you have a balance between your procoagulants and anticoagulants, which are your proteins and zymogens and clotting factors all in the plasma. All right, now I'm going to make a little star. Over here in my blood vessels. And I'm going to put my little star down here. And what that means is I'm going to have my coagulant factors, which I just mentioned. Coagulant factors. And what are those? These are actually enzyme reactions that are going to be happening. We've got like serine proteases. Let me just make sure I spell it right. Serine proteases. Okay, so not only are my blood vessels exposing endothelium, releasing collagen, vasoconstriction that's happening with my blood vessels, I'm also having coagulation factors that, because I have a phospholipid layer here, I'm going to be able to get my coagulation factors to work on my blood vessels and my surface area to start forming the clots. All right, so what you need to remember is that the coagulation factors, they need to go to thrombin. Thrombin, very, very important. I've got to get to thrombin. All right, so now, this second half, I'm going to complete the circle. Okay. This second half of where my coagulation factors are working to get to thrombin is called the secondary hemostasis. Okay, so again, primary hemostasis represents vasoconstriction and platelet aggregation. And of course, it's more complicated than that. I've got other things are happening. And the secondary hemostasis is the coagulation factors. Well, where are these factors? Well, first of all, where do they come from? Well, they come from lots of places, but most of the time my liver is producing them. So you can see, if I have liver problems, if I have a hepatitis, if I'm, a chronic, I'm an alcoholic, so whatever the problem is with my liver, I can also have a problem with coagulation, because all or like most of my coagulation factors are being produced by the liver. Okay, so they're produced by the liver and they're circulating in my serum or my blood, my plasma. Now over here I said they were enzyme reactions. I'm going to put them over here. These are enzyme reactions. Enzyme reactions. Well, my coagulation factors are circulating, but they're circulating in an inactive form. All right, coagulation factors are circulating in an inactive form, and those are called zymogens. So they're circulating inactive. Well, when these coagulation factors are circulating inactive form, and then they get in contact with a blood vessel, they see the cells, they see the collagen, they see the platelet phospholipid surface area, they're going to go like, woohoo! I'm going to stop and I'm going to get all excited, and now I'm going to work as an enzyme. All right. Woohoo! That's a lot. So remember, primary hemostasis, platelets, blood vessels, vasoconstriction, platelet aggregation. Secondary hemostasis are my coagulation factors and the interaction that they have with my vessels and my platelets. Okay, so this is primary hemostasis, secondary hemostasis. And then, okay, so what happens, I have a note here, what happens if I am out of balance? I'm hoping you're answering that question. What happens if I'm out of balance? Well, if I have too many procoagulants, I'm going to clot. If I have anticoagulants, I'm going to bleed, right? So we have to have that fine balance between bleeding and not bleeding. I got to keep it together. Okay, let's see. What happens if I'm out of balance? Well, I'm either going to bleed or I'm going to clot. All right, the term you need to know for a clot is a thrombus. Okay, thrombus, that's your clot. And you need to know that it means pathologic clotting. Okay, thrombus, pathologic clotting. So I could, throw a thrombus. I can throw a clot. What does that mean? The clot has gone away from the original area that it was, healing or something, and it went to another place, such as the lungs. Oh no, now I've got a lung problem. Oh no, now I have a deep vein thrombosis. Oh no, now I'm having a stroke or I'm having a heart attack. So when these clots get dislodged and they go somewhere else, it's a pathologic condition and it's called a thrombus. All right, so that's that's basically what you need to know about primary hemostasis and secondary. Now that wasn't hard, right? So what you need to remember, what components are primary hemostasis, what components are secondary hemostasis, and they work together. Now, that was very simple. You're going like, well, what are you freaking out, Dr. Torres? That was like really, really easy. Well, it's really complicated on how the lipid surface area comes in and the sequence that's happening for my coagulation factors, and how does it keep it in that little area so that it doesn't get dislodged and become a thrombus. So that's really, really important for you to know. All right, so I had a few more little notes here for you. And all right, to stop the bleeding, and your paper should probably look a little bit like that, okay? To stop the bleeding, we've got to have vasoconstriction of our blood cells. Over here, when we're talking about our platelet aggregation, okay, over here it's really another process. Oh, can you see that? Let me write this down over here. All right, this platelet aggregation is really like another process where we're going to have platelet adhesion, and then platelet aggregation, Then we have consolidation. I don't have that on yours. Consolidation. Okay. And so this is a bigger process. So again, to go back to what you need to stop bleeding, number one, vasoconstriction, platelet aggregation and adhesion, and we need our coagulation enzymes to be activated. In order to stop bleeding, I need all of this to be working together. All right, now, over here, I was mentioning about the endothelial cells, the blood vessels, etc. So we have to have key cellular elements for this. All right, so what are they? They are the cells of the vasculature. So we've got the blood vessels and we've got basal membranes, etc., etc. So we have to have the cells of your vascular intima. We have extravascular tissue factor. All right, so when I'm breaking open my blood vessel, I'm going to be releasing tissue factor. I've got to have tissue factor to help this process occur. All right. And then I need platelets. So 3 kinds of cells that you need to work to help make these clots. Number 1, the cells of my blood vessels. Number 2, I need extravascular tissue factor cells that are going to be doing that, the cells that are going to release the tissue factor, and I need my platelets. Okay, so those were cellular components. Now I need plasma components. So what are the plasma components that I need? Well, I need my coagulation factors. Where do those come from? The liver, right? Coagulation factors. And I mentioned that the minute we start making the clot, I am dissolving the clot. I put in my system to dissolve that. So the system to dissolve that is called your fibrinolytic. I'm wondering where I can write that. I don't want to write. Okay, I'll just put it over here. So I'm going to have to do this. I need my fibrinolytic. What does that mean? Okay. Coagulation factors are coming together. They're working with the blood vessels and the platelets to make thrombin. Thrombin is going to go to fibrin. Fibrin is what makes the mesh in my clot. I don't know if you've ever looked at your scab or taken a scab off your skin and you kind of look at it. It's kind of reddish because that's the red cells, the blood that got caught in there. But when you look at it closely, it's got like this mesh type thing in there. The mesh type thing there is the fibrin. So when we are doing this, I also have fibrinolytic to destroy or to dissolve fibrinolytic proteins in there. And at the same time, I have to stop this process from going bazonko and going crazy and making clots everywhere. So I have to have inhibitors all at the same time. Whew, what did I just say? All right, so go back to your notes that I gave you, and it says 1B up at the top. 1B up at the top is telling you, well, what do I need to stop the bleeding? Vasoconstriction, platelets, coag, etc. It's also telling you the cellular components I need for clotting. Okay, I need my blood vessels, I need my cells that release tissue factor, and I need platelets. And I also need plasma components. So what are the components in my plasma? Well, the coagulation factor proteins that are in there. I'm going to need fibrinolytic proteins, and I need inhibitors. Inhibit. All right, so that is what's going to keep everything in check for you so that you don't have a thrombus. So what was thrombus? It was a pathologic clot, which means it's going to cause problems. All right, so that's if it's working correctly. Well, what happens if it's not working correctly, such as if I have inherited disorders or I'm taking drugs that inhibit, right? So some people make clots. Oh, I've got AFib. Oh, so they give you an anticoagulant to do. Oh, before I talk about that, this is my pet peeve. They call them blood thinners. Oh, they're not thinning the blood. All they are doing is making the blood in an anticoagulable state. They don't thin it. It stays the same. It stays the same viscosity. So, please do not use the word blood thinners around me. Please use anticoagulants. Okay. All right. I got distracted. Sorry. Okay. So what happens if this whole system is not working? Well, I can have defects in my primary hemostasis and secondary. First, defects in primary hemostasis can mean I have a problem with my blood vessels. So sometimes people don't have, their blood vessels aren't made correct, so they can have like collagen abnormalities. And so when they have collagen abnormalities, that's going to give them a defect in primary hemostasis. I could have a thrombocytopenia. My platelets aren't there, right? Okay. The other thing I could have is that maybe my platelets are there, but they don't work. So I could have a qualitative and a quantitative problem with that. And there's this other thing we'll talk about a little bit later, and I could have von Willebrand's disease, and we'll talk about that later, but just make a note, von Willebrand's disease. Everything that I'm telling you right now is on your page 1C. 1C. So these are problems that you can have, and if you have problems in those areas, it's going to give you a chronic hemorrhage. That's your primary. Now, what can I have problems with secondary? Well, yes. So what's the major component of secondary hemostasis? Coagulation factors. So if I don't have enough coagulation factors, that's going to problem. If I don't work, that's going to be a problem. So the most, I was going to say famous, not famous, the most well-known hemorrhagic problems that we are occurring with coagulation factors is your hemophilia, right? So we have different kinds of hemophilia, hemophilia A, hemophilia B. They have problems with coagulation factors number 8 and number 9. All right, so chronic hemorrhagic problems with primary hemostasis can occur when my blood vessels don't work. Primary hemostasis problems can also occur if my platelets aren't working, right? Okay. And then problems with secondary hemostasis are going to be with the actual coagulation factors that are there, and they cause chronic hemorrhages. All right, so all of that is in your notes that you have. Now, your page number 2 that I gave you looks a little bit like this. Did you see that? All right. A little bit more complicated, but what I'm going to do is I'm going to erase a little bit here. They gave me this thing. I'm trying to get my Oh well, I'll take it from the outside. Alright, I am going to erase some of this. Or maybe I won't. Let me see. Hold on. I don't know how much you can see. I know you can see that. I'm going to see. You can see that. Alright, I can do a little bit more over there. Okay, so what I'm going to continue with then is the endothelial cells. Very important. I already talked about your endothelial cells. Disruption is going to give me excess bleeding, blood vessel damage, ruptures, abnormal platelets. I've already discussed that. This is secondary hemostasis, primary hemostasis. Your whole coagulation system consists of primary hemostasis and secondary hemostasis. And it stays fluid with a balance between procoagulants and your anticoagulants. Now, the other thing again you need to remember is that I do have fibrinolytic proteins. We're going to get more into that. Fibrinolysis and how we take it apart. Now, this is important. Down in the corner of your paper there, it says the major systems involved here, okay, are going to be your coagulation factors, which we have, and your platelet aggregation, and your blood vessels. Okay, so let me put a green. So, okay, your major systems again, platelets, coag factors, blood vessels. Your minor, so I dropped my top. Your minor, I dropped the marker. Your minor systems are the kinin systems and your complement. The minor systems are kinin and complement. All right, now, normally your hemostasis is going to occur rapidly, first with primary, and then it takes more slowly with your secondary. So you have to remember, when I'm getting a cut or something, it's going to be a rapid, and it's also going to be localized. We need to keep it within the system. What happens if we don't keep our clots localized? I'm hoping you're saying, oh man, I could have a pathologic coagulopathy. I'm going to throw a thrombus, right? And I'm going to have clots everywhere. I could go into DIC or even have strokes that are there. Okay. All right. One thing that I did not put up on here is that, let me see. I'm going to use a different color. I think I can use orange on this one. One thing that is really important, and I mentioned tissue factor. So one thing you need to remember is that my endothelial cells are going to come over here and work with these proteins. And this is activated by TF, tissue factor. So remember, I said these coagulation proteins, etc., it's an enzyme reaction, but they circulate as what we call zymogens. They circulate as inactive enzymes. Well, what's going to activate them is the tissue factor. Well, where in the world are they getting tissue factor from? Well, they got it from the blood vessels that got injured somehow, whether it was like maybe I had bacterial infections and ate up the inside of my vessels or actually cut it or whatever, it's going to release the cells there of the blood vessels. You're going to release tissue factor. So tissue factor helps activate your coagulation factors there. All right. Okay, now, the other thing that is going to be activating your coagulation factors and all of this together, I'm going to put this little orange thing around here, all right, is your platelets, okay? So, when platelets, they are like party animals. They're looking for a place to gather. It's a good thing platelets don't know about our current situation with COVID. But anyway, platelets like to gather together. They do not understand social distancing. Platelets do not understand zeta potentials like red cells, right? So platelets aggregate and they get together. And when they get together, they have a party. So, it's like a little children's party. What do they do at little children's party? Or even New Year's party. Yay, Happy New Year! And they're throwing streamers and blowing their little thingies, right? Platelets kind of do the same thing. So they get together and they get excited and they excrete their contents. Oh, platelets are amazing. So, a note to yourself, well, what do you mean by they excrete the contents? So, platelets, remember when you're looking at them in hematology, they've got all of these little, they look rough, like granules. Well, they have granules inside, dense granules, alpha granules. And so what happens is they excrete the contents of these granules and it helps bring all of this together. I tell you, those platelets, they love to get together. Now, there's a sequence of what we do. I have here. They adhere. First they adhere. So they're flowing along. They're flowing along down the blood vessel. And then they're flowing, and then they're like, whoops, there's a hole. There's a hole in the blood vessel. So they stop, and then they adhere to the blood vessel. Now, if it's really, really bad, whatever, then the next step is going to be aggregation. So I have one platelet that's stuck, and it's saying, hey guys, there's a hole over here. Come over here and help me out. So then all the other platelets come together, and they're getting together, and now like, oh my gosh, we can have a party. And so they get all excited, and they're having this party, and then they excrete their granules. Okay, so when they excrete the contents of their granules, then it helps all this other process occur. Okay, let me see. What else do I have here? I need to do that. Vasoconstriction. Okay, platelets provide the phospholipid. I already put that down for activating. They aggregate. Did I put my serine? Yes, okay, so when I put inhibitors over here, these are serine protein inhibitors. Oh, I have it right here. Serine protein inhibitors, those are the same thing. So remember, you've got those inhibitors that are there. Now, okay, I think you can see, well, what I'm going to do is I'm going to turn this a little bit this way so that we can see a little bit more board. All right, because I'm going to write over here. Okay, so when we got over here to this thrombin, I said thrombin has to go to fibrin, right? So I'm going to go over here. Oh, no. If I turn this off, it's going to be terrible. Sorry. Okay, so I'm over here with the thrombin. Thrombin has got to get to fibrin. Okay, and it does that through this process here. Okay, so when it gets to fibrin, fibrin is going to end up making your platelet plug. Okay, so what that means is I've got my fibrin that's running together with the blood, etc., and it makes the mesh. Once it makes that mesh, it's called the plug. All right, and it comes back over here to your blood vessels. Now, at the same time that I am doing this, I can have fibrinolysis happening, and we're going to get, this is a whole other separate system we're going to be talking about fibrinolysis there, all right? And then we make our clot. Now, right now, this is okay. It's normal. A pathologic clot is going to be a thrombi or a thrombus. All right. And that was it. Those are more of the systems. Now, right now I'm just going, oh, this is going here, and this is going here, and this is, there's a whole big long process of how I get to coagulation, of how I get to thrombin, thrombin to fibrin, fibrin to the way it clots, and how it's working with my blood vessels and my collagen, my tissue factor, and platelets. They all kind of work together. It's like really, really, really pretty amazing. Okay, now that is really kind of complicated there. All right, now this is what's going to happen if I have a hole, right? I cut myself. Well, we have in our system a way to protect my blood vessels from making clots. Okay, so there's a natural protective mechanism to prevent the formation of clots in healthy tissue. Okay. Let me see. So this is on your page number 3. It's up there in the corner. This is on your page number 3. One of the main ways that we can keep ourselves, I'm going to turn this camera back again the other way so you can go back and see the endothelium. Okay. All right. So one of the ways that we keep this is number one, an intact endothelium, meaning there's nothing wrong with the blood vessels. Now, sometimes, you know, we've heard about too much cholesterol and you build all that up in your blood vessels. So when you do that, it makes the blood vessels kind of bumpy and scrapey. Those are considered or it could help you make clots there. So that's the other thing, another reason why they don't want you to have all this cholesterol in you. So a normal, clean endothelium is a natural way to keep my body clean and clear from making clots. Because, why? Because, number one, it is non-reactive. It's non-reactive. And number two is that it is thrombin resistant. And how does it become thrombin resistant? Because it has the interaction of receptors and proteoglycans that are going to bounce off, and I'm going to show you how that actually works with nitric oxide and some other things that we have. Okay, so how do we keep how do we prevent the formation of clots? Number one, a normal intact blood endothelium, and number two, by these coagulant factors roaming around and circulating as inactive forms, as zymogens. Okay, so your procoagulant factors, they're held in balance by your anticoagulants and your fibrinolytic system. Keep it in check. And the platelets have a procoagulant membrane on them too that helps, and they helps within the cells to keep that not making a clot at the same time. Okay, so normal ways to not make clot. Number one, good endothelium. Well, how? That works in two ways, by it being non-reactive and by it being thrombo-resistant. And what do we mean by thrombo-resistant? Thrombin, thrombo-resistant, okay? And the second way we keep normal, not making clots, is by having my coagulation factors circulate as zymogens. All right. Now, once my clot is formed, it's going to dissolve by my fibrinolysis, which I mentioned before. And we have proteolytic enzymes that are actually incorporated into the clot when it's being made. Okay, what's plasmin, plasminogen, we'll get into that, etc. And a really important thing for you to remember is PDGF. PD, so my blood vessels make, right? PDGF. They secrete that. Oh, you can't see that. All right, I wrote over there. PDGF. Okay. PDGF. Okay. What that stands for is, you should know because of your hematology and talking about some other stuff, that is your platelet-derived growth factor. So, well, what in the world? That's supposed to be working on platelets, but what you don't know, because we've just been talking about platelets, etc., is that the platelet-derived growth factor actually helps in the healing of the blood vessels. Wow, isn't that amazing how all of these things kind of work together? Amazing. Okay, let me see. Oh, this is dry. I wonder if this will work. Let's see. Doesn't work too good, but I did bring a spray with me. I have a spray. Okay, so again, you have all this. I gave you my notes. I uploaded them for you to have. Hopefully it will going to be okay. So what I want to do next is just kind of make, I think I sprayed too much of that. It's kind of gooping everything. Make some general comments. Oh, too much spray. Sorry. Okay. Get my hand. All right, let's put you back in the center. Okay. General comments and some things that you need to remember. That's still wet. I don't know if it will. Number one, let's talk about mucocutaneous hemorrhages. All right. Well, so first of all, what is a mucocutaneous hemorrhage? Well, from your mucous membranes. Okay, so that's what it is. if I have, so when you're reading your case studies or just reading the test questions, blah, 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 bleeding gums, blah, 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 nose bleeds, okay? Things like that, those are considered mucocutaneous hemorrhages. So, when we look at mucocutaneous hemorrhages, you have to think that I have a platelet disorder. Okay, this platelet disorder could be a qualitative or quantitative. So it could be qualitative or quantitative. Okay, so that's the first thing you need to remember is if I've got a mucocutaneous hemorrhage, bleeding gums, nose bleeds, ulcers, GI bleeding, bleeding in my urine, petechiae, things like that, you need to think that I have a platelet disorder. Okay, well, what kind of platelet disorder? Well, it could be qualitative, maybe they're not working and they're not aggregating and maybe they want to be loners or whatever, don't want to come to the party, they're not working, or it could be you don't have enough. All right, now the second type of general comment we need to make is about joint hemorrhaging. What in the world is that? Joint joint hemorrhage. Okay. And retroperitoneum. And retroperitoneum. All right. So when we've got bleeding into, oh, you can't see my knee, bleeding into the joints like knees and elbows and shoulders and anywhere like that, if I'm bleeding into that, you need to know that it is due to a factor deficiency. Well, what does factor deficiency mean? The Coag factors. Coag factors. Okay, so we'll get into Coag factors in a little bit, but again, please go to your tables and your boxes are going to list all the coagulation factors, list what they do, etc. Okay, the other thing you need to think of is that maybe I'm on anticoagulant therapy. Did I do this right? I'm trying to make an arrow. Okay, if I go that way. Like warfarin, Coumadin, therapy or toxicity because it's too much. Okay, so anytime I have any of this kind of hemorrhaging, I have a coagulation factor or I have a anticoagulant medicine given to me like warfarin or Coumadin, and it's too much. It's toxicity. Okay. Okay. Now the other thing that we really important, and you already know this too. Did it come out? Can you see that? It's the DIC. Can you see that? I don't know. DIC. All right, DIC. No, you can't see that. How do I get you down? Anyway, okay, number 3. Number 3 is the DIC. All right. We talk about DIC, disseminated intravascular coagulation. It's, I'm making clots and everywhere. But what you need to remember is when I'm doing or making these clots in the DIC, I am using up my coagulation factors and I am using up my platelets. So the DIC can have both mucocutaneous and my joint hemorrhaging. So I could have mucocutaneous and I could have this. So in the DIC, I have both that are occurring. Okay. I think that's pretty good. So we need to make sure that you remember plasma components for hemostasis are the coagulation factors, your fibrinolytic proteins, and your inhibitors. And the cellular components of hemostasis are the cells of your vasculature, the extravascular tissue factor bearing cells with that, and the platelets. All right. Let's see. This is just a review. Your pages that I gave you of your notes that say 5, 6, and 7 are basically a review, and I think that my video here is getting too long. I haven't noticed how long I'm talking, but if it gets too long, I can't upload it. So by now, I'll make this a part 2. Bye.